storage spaces. In fact, we're going to talk about it now. So, anyone here not doing RAID? Stick your hand up and live in shame. Video cameras watching. Anyone need RAID explained? Okay, good. So RAID, ability to take lots of disks, aggregate them, and get fault tolerance or resiliency for those disks. We can set hot spares, so if one of them fails, another one kicks in automatically, so we don't get any drops in performance or anything like that. And it potentially allows us to lose another disk just in case, without losing the entire LUN or the virtual disks that are on that disk aggregation, like in a SAN. It's expensive, because you've got a RAID controller there. You're adding more bits of hardware. Now for one or two servers, maybe not a big deal, there's a RAID controller in there. But let's start thinking bigger. What if you are in an environment with thousands of servers? Every time you put in a new server, there's a RAID controller in there, that's another €100. That thing's sucking up another few watts of power. This stuff adds up over time. Microsoft wanted to look at RAID, and in fact they looked at the entire storage in a data center and wanted to give us an alternative. Now I want you to keep this in mind. This is not the RAID you saw in Windows beforehand. Whoever did RAID in Windows 2000 or later? 1, 2. Whoever did a 2000 certification? Same hands pretty much. You were guaranteed 3 or 4 questions on Windows RAID, and they were awful because the answers were so obscure and convoluted. And to be quite honest, Windows RAID sucked. The performance was awful. You were better off just spending the few €100 on the RAID controller. And if something did go wrong, and it needed dynamic disks, which just about everything else don't support. So Microsoft went after that and said, let's give us something new where we can aggregate these disks and create disk fault tolerance pretty much the same way that a modern SAN does. Except we can see how modern SANs are working. We've, 20 odd years, how long have SANs been around? 15, 20 years? Thereabouts. We can learn how they've been doing things. They haven't really changed that much, how they treat disks. And there's some limitations in there. Let's get around that. And let's do it using software definitions, which means we abstract the physical hardware that's underneath. So maybe I buy a NetApp, an EMC that, storage tech this. Deploy them. I use the technique in every single separate set of tools for everyone. So that's what Microsoft wanted to do. So, in fact, this is better explained with an image. I can get myself a bunch of disks. You want to try this out? Pop a few USB disks into the back of a Windows 8 laptop or PC. You can try it right there. In the server space, get yourself what we call a JBOD, just a bunch of disks. Just a bunch of disks, or JBOD, is way cheaper than your traditional RAID, DAS, or SAN. Way cheaper. Back in the day, 5, 6 years ago, company I worked for bought a starter kit fiber channel SAN. It started off with 8 terabytes of disk, and it was €50,000 on bid price. It was a fiber channel SAN. That's pretty expensive drives. Not long afterwards, we were talking to the sales guy from the same reseller, and he said, if you just want cheap, big disk, I've got this JBOD, 75 terabytes, €21,000. 75 terabytes, €21,000, versus 8 terabytes for €50,000. The problem with the JBOD is it didn't have disk fault tolerance. It was lots of individual disks. I would have had 100 and whatever disks in individuals. Would have been nasty. But now we've got storage spaces. I can create a storage space to aggregate those disks. By doing that, they actually disappear from disk management. They appear as a pool, a single entity in Server Manager. This is, if I know the HP terminology for storage and stuff, this in HP world would be a disk group. Single entity of disk. Anytime I deploy storage from this, that storage will actually live across each of these disks. When I'm creating this, I can actually designate one or more hot spares. So if one of these physical disks dies, the hot spare will kick in. From this, I can create virtual disks, and they can have different levels of fault tolerance. So in this case, I've created what we call a two-way mirror. This is kind of like RAID 10, but it's not RAID 10. Because the RAID we've been using in the past is kind of limited in some ways. I could quite happily buy these 6 disks. Maybe I get 6 2TB disks from Dell, and I'm quite happy with them. I live with that for a year, and then I go back to my Dell sales guy and I say, listen, I need more disks. Can you give me more storage space, please? And they'll say, well, we don't have the 2TB drives anymore. We've got the 4TB drives. They're fantastic, and this, that, and the other. And you think 4TB drives, fantastic. If I put those into my RAID array, I would only get 2TB of storage space out of each of them. But storage spaces, it will actually drives. There's a process called interleaving. Sometimes you see these things being referred to as slabs. Basically, it's consuming 256 data from. It's consuming a bit from here, consuming a bit from here, duplicating it to here, consuming a bit from here, duplicating it to here. Pretty much kind of like RAID 10. So if I lose this disk has the data. And I get no rewrite penalty with this, just like with RAID 10. There's even a 3-way mirror. So now, anything I store here is also here and here. Possible implementations with this mirroring stuff is you don't have just one JBOD tray, you could have multiple JBOD trays. So any data I put on tray 1 is also on tray 2. So if I lose the entire tray, my data is still up and running. That's one of the other nice features of a nice expensive SAN, where they do this RAIDing between disk trays. Now we're just using dumb JBOD to do this. We got simple. I don't know why in the real world other than non-persistent caching, but here basically it's consuming interleaving across all the disks with no fault tolerance. So again, no impact or cost for read-write performance. And then finally we have parity, kind of like your RAID 5. So we can lose a disk and the volume stays up and running, lose 2 disks and we're in trouble unless we've got hot spares that have kicked in during the disk failures. And there is a penalty on write performance, just like with RAID 5. So that's how it looks. That's a simplified view of how it looks. Let's actually build it. So, word of warning, I do not have a JBOD. What I have done is I've created a virtual machine that has 8 virtual hard disks attached to it. And I'm going to create a storage space inside the virtual machine. This is not supported. Storage space is supposed to be done in physical machines, storage servers. It is not supposed to be done inside a virtual machine. If you need a big volume in a virtual machine, use a VHDX file, which can grow out to 64 terabytes. And you've all said you don't need more than 64 terabytes. So, okay. So here I have a machine, and open up disk management. And you can see it's got lots and lots of disks there. It's actually got 8 unallocated disks. And in Server Manager, storage pools, you can see I've got this primordial thing. What I'm going to do is say new storage pool. Next, give it a name. Next, select the disks that I want to put into this. If I did have actual physical chassis, you'd even see some information about there. Under allocation, I can set some disks to be hot spares. So if one of them fails, the hot spares will kick in. It's pretty much everything you're seeing so far from a SAN when you create a disk group. Next, create. So now all it's doing is aggregating those disks and identifying the hot spares. So that's done. And what I've just done there can also be done in PowerShell. So it could be something that you do once and repeat many times using a PowerShell script. I've got 74 gigs of total storage available to me now at that point in that storage pool. Now I want some LUNs. HP World, we'd call the LUNs virtual disks, and funnily enough in here, they're called virtual disks. And select my pool first. Tasks, new virtual disk. Next, select where I'm creating it. So my storage pool, thank you very much. And I'm going to call this two-way mirror. Next, select my fault tolerance type. Simple, no fault tolerance or resiliency, mirror or P. I'm going to go with mirror. And when we do mirror, I can choose between two-way mirror and three-way mirror. Next. Cool thing with this is I can thin provision. Allocate more space to that LUN or that virtual disk than I actually have available. And it'll only grow it as it needs to. When we get to the 70% mark, it'll actually alert us. Again, this is going to work better when if you've got System Center to actually let you know, because you're hopefully not sitting there pressing F5 on the console looking at this thing. So you will want alerting. So let's go alerting. I had 74 gigs there. Yeah, 74 gigs sounds good, but I would like 5 terabytes. Next, create. And box down here is checked, so I can format the volume and actually use it. Next, volume size, yeah. Do I want to give it a drive letter? Sure, why not? We have an option for file system. How many people have heard of REFS or EFS? One, two, handful. It's kind of what we typically expect. Unless you're reading certain blogs, you typically don't hear about REFS. REFS is Microsoft's new file system. It's not necessarily what you're going to use right now, because you can't boot from it. There's certain things like cluster shared volumes and don't support it. But it is where Microsoft are going. It doesn't need check disk. Actually, it doesn't have a check disk. You can't use check disk on REFS. It's its own fault tolerant thing going on in there, its own repair process going on. But we still have good old NTFS. NTFS is there since the first version of Windows NT, which they started developing, I think, in '91. Dave Cutler and those guys when they left the VMS world. And it's grown over the years, but it's an old file system. And Microsoft want to give us a new file system for the future. So it's in there for certain things if you want to use it. But two-way mirror will be the name of the volume when it's just formatted. I'm not going to talk about data deduplication yet. We'll come back to that later. And create. And it takes a few seconds, and when it's done, I'll have myself a 5 terabyte volume on my 74 gigs of storage. Now it's going to be up to me to monitor this to make sure that I actually keep popping in disks into my storage pool to live up to that promise that I've made. This is a stupid promise to have made, but it gives you an idea of what you can actually do. So now if I open up Explorer, I now have a two-way mirror, and it is 5 terabytes in size. I just don't want to store 5 terabytes in there because I don't have enough room in my lab to allocate storage to it. And if we go back and look in the storage pool, we can see that I have my 2 hot spares marked out there. Now your JBOD will have to support something called SES. I think it's SCSI Enclosure Services or something, version 2.1. Ideally, it needs to be on the hardware compatibility list for Windows Server 2012 with the storage spaces functionality. What the SES protocol does is it allows Windows and the physical storage in the JBOD to actually communicate with each other. So if a physical disk goes offline and Windows detects it, it'll tell the tray and instruct the tray to light up the relevant lights. Vice versa, if the tray detects the disk goes offline, it'll tell Windows and then the hot spares can kick in. One of the reasons this isn't supported in the virtualized world is if I kill these virtual hard disks in my virtual machine, we don't have that physical communication process going on. It wasn't designed for that. So I could actually kill one of these virtual hard disks. We won't get the hot spare kick in automatically. What I would have to do at that point, in fact, hell, let's do it. Where have I stored the VM? Please don't look to see what operating system this host is running. I haven't had a chance to rebuild this one. All my other hosts are 2012. Settings, and that's not it. It's actually, believe it or not, on the host I was on originally, the 2012 one. I have too much stuff going on. I have layers within this lab. It's crazy. This is 2012. SCSI, settings. Let's kill that disk, remove, apply. And now go in here and we will refresh. Now if we had the physical communications in there that the SES protocol would give us, this thing would know automatically and would start doing the repair process. But because we're dealing with virtualization in an unsupported configuration, doing storage space inside of EM, I don't have that communication stuff going on. So this, when it refreshes, you can see the two-way mirror now has an alert state. And down here, we can see I have a disk that's offline. This will actually refresh in a little while. Actually, when I do this, repair virtual disk, and now refresh the console, and we should actually see one of these hot spares has now turned into automatic. It's gone from hot. So if we did have that SES protocol in there, that would have all happened for us. Or if we were just using physical disks popped into the back of a machine like USB or something, Dave does this himself, it would have done it for us. But I'm doing this in an unsupported scenario just so I have enough gear to show the functionality. Sorry?
What system center picked that up? You know, it's unsupported configuration. Could you got system center reporting that and it takes it all down?
That's a good question. Would Ops Manager detect that, Kev?
The new management pack is due to be released in the next quarter. That should pick them up,
Okay.
but not yet.
You could probably customize that anyway yourself.
Yeah, easy, yeah.
So that's storage spaces. So that gives us a RAID equivalent. Performance-wise, this thing performs, trust me. I will talk more about performance stuff in a little while when we get to the thing that you're really going to start questioning. So, because we're dispensing with hardware RAID, we've got cheaper aggregation of disks. We're able to use dumb JBOD. In fact, the requirement is no hardware RAID. Hardware RAID in between the disks and the server will actually break this. So we need no hardware RAID, which is even cheaper storage. It's software definition. So we've abstracted the hardware. We don't have one set of skills for HP storage and another set of skills for NetApp storage. We have Windows storage spaces. So for that larger environment, or that company that has heterogeneous storage policies, or a service provider who's dealing with lots of different stuff and different customers, we can start moving to one set of skills. That is Windows. And potentially you can even PowerShell this, so you have a standardized deployment. And this is the start of a strategy. This isn't something that Microsoft are just throwing out there and saying, let's see what happens. This is a big strategy. And once again, this is not Windows RAID of the past, which sucked.